In this video, we will discuss about various thermodynamic process and the laws of thermodynamics. So, thermodynamic process, it is a process when a thermodynamic system, it changes from one state to another. So, these are various thermodynamic process, that is isothermal, adiabatic, isochoric and isobaric. Now, let us understand these terms. Isothermal means, iso means same, thermal means temperature. So isothermal process, it is that process during which the temperature of the system, it remains constant. So dt is representing here change in temperature, so that is remaining 0, constant. So such process is known as isothermal process. Second is the adiabatic process, in which there is no change in the heat content of the system. So if you see here in this, the change in the heat content I am denoting by dH. So dH I am taking to be 0. So in this case, no flow of heat will take place across the boundaries of the system. So in this you can see dH is taken as 0. Next is the isobaric process. Again, iso means same. So isobaric process, in which the pressure of the system, it remains constant. So if pressure is constant, we will denote it by dP is the change in the pressure, so I am taking it as 0. Next is the isochoric. Again, iso means same, so the process during which the volume of the system, it remains same, that is known as isochoric process. So dV, that will be taken as 0, there is no change. Next one is the cyclic process, that is when the system return to its initial state after completing the process in various stages, that will be the cyclic process. Reversible process, in which can be reversed by minor changes in the properties of the system. In this system and surrounding, they always will be in the equilibrium. Irreversible process, which cannot be changed even by bringing small changes in the system, that will be irreversible process. Endothermic processes, in which amount of energy is absorbed during the reaction, and exothermic processes is in which the energy is evolved during a reaction. In case of heat, if we say heat will be given out. Spontaneous process, it means continuous till the end, and it starts by its own or in presence of some external force. Example is the evaporation of water. Non-spontaneous processes, it will occur only some external work is carried out, and it will remain till the external factor is working. If you remove the external factor, it will stop. Example is electrolysis of water. Now let us talk about the relationship between heat and work. What will be the sign? Heat, it is a way to transfer energy from one body to another by difference in temperature between the bodies, whereas work is the link between system and the surrounding for the transfer of heat energy. Now in a system, if heat is evolved, then Q will be considered to be negative, whereas if it is absorbed, then Q is taken to be positive. Similarly, when work is done by the system, W is negative. When work is done on the system, then W is considered to be positive. Let us talk about the internal energy, that is the sum total of all the different energies of the system. And internal energy of the system changes when the heat is flowing in and out of the system, when work is done on or by the system, and when matter leaves or enter the system. Similarly, entropy, that is the disorder or randomness of a system, denoted by S. And if delta S is positive, it means that the system is more disordered, and it is calculated as delta S will be the entropy of the product minus entropy of the reactant. At constant temperature, for a finite change, it will be Q by T. This is dQ. So change in entropy, that will be equal to dQ by T, or dQ will be equal to this. If you cross multiply, that will go here, that will be TdS. Now let us come to the law of thermodynamics. As you all know, there are three laws of thermodynamics, first, second and third law, but one more law is there, that is known as the zeroth law of thermodynamics. And actually this law came into existence after the laws of thermodynamics were already established, but since this law is considered to be very fundamental, so it was given lower value, that is zero order. Now this law was given by Ralph H. Fowler. According to this law, if you can see the diagram here, let us say two bodies, 1 and 2, they are in equilibrium with the third body. So if two bodies are in equilibrium with the third body, then automatically they will be in equilibrium with each other also. So that is the basis for measuring the temperature. So let us say that this temperature T1, that is in equilibrium with T3. T2 is also in equilibrium with T3. This follows that T1 will be equal to T2. So as a result, no heat flows. Next one is the first law of thermodynamics, that is nothing but the law of conservation of energy, which states that energy can neither be created nor destroyed, but can be transferred from one state to another. That is the, in simple language, this is the definition. So it deals with the interconvertibility of work and heat as forms of energy. By equation you will denote it by delta Q is equal to delta E plus delta W, where, as you know, Q is the heat energy supplied to the system, E is the internal energy. You can write delta U also in place of E, and delta W is the work done by the system against the external force. Now let us explain it, that this change in internal energy, actually delta E is a state function, so the change in the internal energy depends only on the variables of state like the temperature, volume, etc., and it is independent of the path which is taken from the one state to another. So heat and work, they depend on the path taken. Let us consider a cylinder which is fitted with a piston, as you can see here, and it is filled with a gas. Now on expansion by the gas, force will be exerted by the gas on the piston, and that will be given by force is equal to PA, let us say. Now the during the expansion, the piston, it moves. Earlier it was up to here, and now it has moved here, so it is covering a distance of delta X. So the work done will be given by force into displacement. So force, you know, that is PA, and displacement is delta X, so it will become PA delta X, as you can see here. Now this A delta X is nothing, that is the increase in the volume of the gas. So work done will be equal to P delta V. So if in this equation work is done on the system, positive sign will be used, and when work is done by the system, negative sign will be used. So this was about the first law of thermodynamics, although they are having certain limitations, because it cannot explain why chemical reaction does not proceed to completion. It is not able to predict the feasibility of a process, and unidirectional behavior it cannot explain. It cannot explain the extent of conversion from one form of energy to another. And according to this law, the difference between spontaneous and non-spontaneous process, it is of no significance, and it cannot explain how the naturally occurring process occurs in a spontaneous way, leading to equilibrium. Now let us talk about the enthalpy, which is denoted by H. It is a new state function, and it generally measures the heat of reaction at a constant pressure. So enthalpy is the summation of internal energy and PV, pressure volume product. Now the change in enthalpy delta H will be equal to delta E plus now one time you will be changing the volume, other time you will be changing the pressure. So it will be P delta V and V delta V. Now let us say if pressure is constant, so H is equal to E plus P delta V. Now let us try to find the relationship between the enthalpy and internal energy in terms of number of moles of gaseous reactant and product. PV, as you know, if you apply the ideal gas equation, PV is equal to nRT. So PVA for NA moles, it will be NART. PVB will be NBRT, where Na and Nb, they are the number of moles. And breaking of existing bond and formation of new bonds, that results in a chemical reaction. So PV, this on subtraction you will get this. So you will get P delta V is equal to delta nRT. So you have the value of P delta V that you will put in the first equation, where you got delta H is equal to delta E plus P delta V. So instead of P delta V, you will be writing delta nRT. So this is the equation for the enthalpy. Enthalpy of a reaction delta H can also be calculated using the difference between the enthalpy of the product minus enthalpy of the reactant. So for calculation, first of all, you have to see that you balance all the chemical equations, and all the reactants and products, they should be written in the gaseous state, and after that you will be considering the equation, that is summation of H when bonds were broken in the reactant, and summation of H when bonds they are formed in the product. Now when we calculate the enthalpy, it is generally denoted by delta H. It can be positive or negative depending on the energy required or released during a reaction. If energy is required, it will be positive. If energy is released, it will be negative. So this is how, using this equation, H, that is the enthalpy of formation, can be calculated. So you can use delta H is equal to delta E plus P delta V also, and P delta V is nothing but the work done, so you can replace it by W also. And according to the first law of thermodynamics, you know, delta is this Q minus W. So put this equation, this gets cancelled, and you are left with the delta H is equal to Q. Now relation between delta H and delta E, this we have already done. Now let us talk about the heat capacity. It is defined as the heat which is required to increase the temperature of the system by 1 degree. And specific heat capacity is the amount of heat absorbed by 1 gram of substance to increase the temperature by 1 degree. And molar heat capacity is heat absorbed by 1 mole of a substance to increase the temperature by 1 degree. Now from the definition of enthalpy, we already know this equation, that is delta H is equal to delta E plus P delta V. Now let us differentiate it with respect to temperature. That will be, this will be dH upon dt, dE upon dt, and dPV upon dt. But PV is RT, so instead of PV you can write RT also. R is a constant, so this will be dt by T. This gets cancelled, you are left with R. Now you are having dH, rate of change of enthalpy, and rate of change of internal energy. Now rate of change of enthalpy, that is nothing but Cp, and rate of change in internal energy is Cv. So put this in the equation. So final equation you will be getting Cp minus Cv is equal to R.